Hi everybody, this is Peter Lum with NFace's Training and Education Department, and I'm here at our Fremont Training Labs, and we're going to be talking about commissioning NFace systems using the NFace Installer App. To commission NFace systems, you'll need the very latest NFace Installer App, which I've loaded on my phone. I'll go ahead and tap that. I'll check that I'm actually logged in as a user for my company so I can see the systems that I will be working with. I'll go to Settings to make sure I have all the proper settings. I'll look for the latest software to make sure that I'm up to date. In this case, my Envoy software and Grid Profiles both show up to date. And lastly, I'll just go down and check the version of Installer App I have to ensure that this is the latest version available from my local app store. Once I've verified all of these, I'm ready to start commissioning my systems. Now that we're ready to commission a system and I've opened my Installer App, I want to go to the Systems area of the Installer App, pull down to refresh the list of systems that our company is working on. Now, if our company has created the system ahead of time, which is our recommended best practice, then I should be able to find the system in my list. Our system is called the Training System 1, so I will go ahead and search for this. Once I found the system that I'm commissioning, I want to go in and check the system details, quickly scanning through to make sure that all of the information is correct. If it is, we can go back and continue on. If your company hasn't created an activation for you to access, you won't be able to find it in the list, and so you'll have to create your own. We'll do this by tapping the plus sign back in the Systems tab, and we'll start adding information. So we'll start with the system details. And we'll go ahead and save all of this with the system created successfully.
In this step, we're going to define the devices that will be configured in this system. To do this, we'll have to tap on the Devices and Arrays step. In this system, we have one IQ gateway, a number of microinverters. We can tap the plus button multiple times to increase the number, or if you have a lot of microinverters, you can tap on the number area on the screen and input the specific number. We'll configure how many system controllers we'll have. We'll also configure how many batteries, how many range extenders, a generator if we're adding one, and how many IQ load control devices. When you're finished, you can click Continue. If there's a note that pops up, remember to read it for important messages and updates. Up next, how to scan in all of the system device serial numbers. After you finish the previous step of programming the count of your devices in the Installer App, you'll automatically be directed to the screen to scan in the IQ Gateway serial number. The page will look like this. If you ever get lost in the app, you can always get back to this page from the main screen. Tapping the back arrow will get you to previous screens and eventually to the main system page. From the main system page, tap Devices and Array, and then tap the Scan button for the IQ Gateway. This will bring you to the Scan Device screen for the IQ Gateway. Tap on Scan Device, which will turn on the camera on your phone or tablet. Locate the gateway serial number on the combiner box or the standalone gateway if you're using one, and scan the serial number using the phone's camera. If for any reason you can't scan the serial number with your phone, you can manually input it by using the Manual Input button. You'll have to be very careful to input the serial number correctly. Mistyping the serial number will affect commissioning and operation. Next, we'll need to scan in the microinverter serial numbers. From the Devices and Array page in the Installer app, tap Microinverters and Array. This will bring up the camera again. I'm going to use the Auto feature, which allows me to scan one microinverter right after the other without having to stop, which is very useful since I have quite a few microinverters to scan. The scanner won't pick up the same serial number twice, so I can keep scanning until the full count of serial numbers are captured. Now we can proceed to create an array map and map microinverters to positions in the array map. Watch the lesson on how to create an array map or skip to the next lesson.
To create an array map on your phone and in the app, tap the Array section, tap Array Builder, click the blue plus sign on the bottom right, define your array name. We'll call ours Array 1, and then define how many rows and columns. In this case, we have 10 microinverters. That will be 2 rows and 5 columns. Define whether or not it's in portrait or landscape. In this case, it will be portrait. And then we can define an azimuth and tilt. We'll just leave it at default for right now, 180 with a tilt of, let's call it 15 degrees. Then we'll click Done and Add, and it will create an array structure for us that we can map our inverters to. To save your work, press the blue Save button, and then you can exit. Once we've created an array structure, then what we should do is go and assign serial numbers of what we've scanned in into their specific positions. So to do this, I'll go to Array Builder, I'll tap on the specific module, and it will give me a list of microinverters that I've scanned in. I'll choose the appropriate serial number and assign it to that location, and I'll do that with every one of my microinverters. And I'll do this until all of them are complete. When I'm completed, press the Save button to save my work, and then I can exit.
Next, we'll scan in the system controller serial number. From the Devices and Array page in the Installer app, tap on the System Controller section, which will again use the camera in your tablet or phone. Locate the system controller serial number barcode or the QR code on the inside of the system controller door and scan the serial number in. After scanning, a pop-up will ask you if this system is being configured as a whole home backup or partial home backup. Select which one is right for your system. Tap if you have any large loads you will be configuring to bring up an information window. Click Done to complete this section. When installing batteries, we will need to scan the battery serial numbers in. From the Devices and Array page in the Installer app, tap on the Battery section, which will again use the camera in your tablet or phone. We will have to remove the covers and locate the serial number QR codes, which are on the front of each battery unit. I'll scan all the batteries that I have installed in the system one right after the other. Tap Scan Device on the app and then use the camera on your phone to scan in the QR code on the front of the first battery. Once it's scanned in, select the scan device for the next battery and use the phone or tablet camera to scan the next number. In this system, we have 8 batteries, so I'll repeat the process for each of the batteries until all of my batteries are scanned in. NFace IQ5P batteries must be installed with the System Controller 3 Standard or 3G, the generator configured version. If you're installing a System Controller 3 Standard, it can be configured with a maximum of 8 IQ5P batteries. With NFace PCS software, up to 16 batteries can be installed in a System Controller 3. To install 8 batteries into a system controller without PCS, 4 batteries would be wired into the System Controller Battery DER Distributed Energy Resource port, and another 4 batteries could be wired into the second additional battery port labeled DER3. With PCS, up to 8 batteries could be wired into the battery DER port and another 8 into the second additional port DER3 for a total of 16 batteries. If you're installing a System Controller 3G, the third DER port is dedicated for the connection of a generator, so batteries can only be connected in the one storage DER port. For a System Controller 3G without PCS, this means it can be wired with a maximum of 4 batteries without PCS, but up to 8 batteries with PCS software. I'm commissioning a System Controller 3 Standard with 8 batteries and no PCS. After scanning all 8 of the batteries, I have to tell the system which batteries I scanned in are wired and configured into the additional battery DER port. I do this by selecting those serial numbers of the batteries. All the unselected ones are going to be configured into the standard battery DER port. When you have selected the batteries to be configured on the third DER port, click Save to save the settings. You can confirm that you successfully scanned 8 batteries. 8/8 indicates you expected 8 batteries, and you did complete scanning 8 battery serial numbers. You can now move on to the next step of commissioning. In this section, we're going to be talking about connecting the IQ Gateway and provisioning the system. Provisioning is the last step of configuring the NFace Energy System. Provisioning takes all of the information from the installer app on the phone and programs the IQ Gateway to manage, monitor, and operate the system. To provision the system, we have to first establish a data connection between the installer app on our phone to the IQ Gateway. Connecting to the IQ Gateway is step 3 in the overall commissioning process of the installer app. Access the system on the installer app and tap IQ Gateway Connectivity. For the installer app on the phone to be able to connect to the IQ Gateway, we will need to first turn on a function called AP mode on the IQ Gateway. Locate the gateway in the AC combiner and press the button on the gateway briefly and release. The green light will turn on indicating AP mode is now on. With AP mode on the IQ Gateway, tap Connect on the installer app. The installer app will use the phone's Wi-Fi to connect to the IQ Gateway. The phone will connect to the Wi-Fi of the IQ Gateway, and when it's connected, you'll see the orange bar at the top of the screen turn from an orange bar to a blue bar, indicating the phone is connected. When the installer app is connected and communicating with the gateway, you'll see the connection status on the diagram that's pictured on the screen. The picture shows the phone is connected to the IQ Gateway, and in this picture, the Wi-Fi has also been configured so the IQ Gateway is also connected to the internet. If you need to configure the Wi-Fi connection for your customer on the IQ Gateway to communicate with a customer's network, you can do it on this screen by tapping the Wi-Fi section and following instructions. When you've completed the steps to connect the phone and the installer app to the IQ Gateway, and the system is configured onto the customer's local network, you can move to the next step to provision the system. System provisioning is the commissioning step where the system is programmed and configured using the installer app. The system won't function without being provisioned properly. To provision the system, ensure the installer app and the phone are connected to the IQ Gateway, and the installer app shows a blue "Connected to IQ Gateway" message on the screen. Before beginning the provisioning process, the system will check to see if there are any software updates needed and may perform a brief update. I'll want to make sure the cellular modem is plugged into the IQ Gateway. Wait for any software updates to complete and then continue to the provisioning step. To begin the provisioning step, tap on the Start Provisioning Devices button in the installer app. There will be a pop-up notification that the system commissioning must be done by a certified installer. A drop-down list will appear with the names of all the NFace recognized certified installers in your company. Find and select your name from the drop-down list. Another pop-up will confirm that you acknowledge that the system was designed, installed, and commissioned per NFace guidelines. If IQ8 microinverters were installed in the system with a system controller, to commission these, you must also be a certified IQ8 microinverter installer. Find and select your name as the certified IQ8 installer and confirm your acknowledgement. After the acknowledgements, the installer app will start the process of programming the IQ Gateway and communicate with all the devices to program them as well. During the device provisioning process, the system will go through several communication sequences to establish and verify good connectivity. During the process, the NFace Installer App on your mobile device will program the IQ Gateway with all of the devices it will communicate with and manage, starting with the microinverters first, verifying each device, and then to the system controller if configured with one, and then each of the IQ batteries. The final confirmation that the IQ Gateway is configured and communicating properly with each of the devices is a final message showing the device is provisioned. After the system is successfully provisioned, we will have to do some final system configuration steps and operate the system to verify if it functions correctly and as expected. You can continue to the next system commissioning step. In this step, we'll use the installer app to functionally test the system and verify that it's able to operate as it should. In this step, we'll verify proper IQ Gateway wiring, check and verify system metering, both production and consumption, and verify PV, system controller, and battery are operating correctly. To begin this step, access the customer site in the NFace Installer app. Tap the validation stage on the screen. Next, ensure you are connected to the IQ Gateway with your mobile device installed with the latest NFace Installer app. The validation step involves 4 sub-steps that we'll cover one at a time. The first step is checking and validating microinverter production in the system, which is an optional step. The second is checking and verifying the IQ Gateway in the backup system is wired to the right place for power, which is critical for proper system operations. The next sub-step in this sequence is configuring and enabling the system metering. Next, checking and loading base level operating software. And finally, functional validation, which will walk you through the test sequence to verify that the system is working as it should. In this video, we'll skip the microinverter validation step, as that will be covered in a different video. The IQ Gateway wiring check. This step checks for proper wiring of the IQ Gateway. Tap on the IQ Gateway wiring check to start the automated test process. The IQ Gateway power wiring is different for different systems depending if you're installing IQ8 microinverters or IQ7 microinverters. The IQ Gateway wiring substep will check and confirm if you have the IQ Gateway wired into the right place for power for the system you installed. If the IQ Gateway power is wired incorrectly, the IQ Gateway will reboot during the test. If this happens, check that the IQ Gateway power is correctly wired into the system controller. When this test finishes, it will show the substep as completed and you can move to the next substep. Meter configuration. Configuring the meters is critical for proper operation of the IQ batteries. In this substep, we'll configure and verify the production meter, consumption meter, and storage meter if the system has them installed. Tap Meter Configuration on the Installer app. We'll configure the production meter first. It's strongly recommended that you follow the wizard steps to enable the production meter. I'll tap Yes. To start the production meter configuration, the system must be energized and the PV circuits should be switched on for at least 5 minutes when they should be producing power. Click the checkbox to verify the PV has been on for 5 minutes. You'll see the current power production value on the screen. To begin the wizard, when the power production numbers have stabilized, switch off the PV breakers in the IQ combiner to turn off power. It's important that you do not turn off the breakers in the IQ system controller for this. Check the box when you've switched off your breakers. After switching off all of the PV breakers in your AC combiner box or your PV subpanel, the PV production should drop to 0. This verifies the CTs are measuring production and nothing else is being measured through the CT. If you are reading something other than 0, check your PV circuit wiring and ensure PV output wires are the only ones going through the production CT. Enable the production meter by tapping the button on the screen. Configuring and enabling the consumption meter. Tap consumption meter to configure it. A pop-up will remind you the consumption CTs cannot be installed on the load side of the MID. Check and confirm the CTs are not installed on the load side of the system controller. Click and select the diagram that reflects how your system is configured and where the consumption CTs are located. In this system, as an example, it's a whole home backup with the CTs on the main feeders between the utility meter and the system controller. Answer the pop-up question based on your system configuration. The Setup Consumption Meter screen will show the total home loads. This is how much the entire home is consuming. To begin the consumption meter validation, PV must be turned off by turning off the breakers inside the AC combiner box or the PV subpanel. Check the box when you've switched off all your breakers. With the PV turned off, the meter readings in the Installer app are showing just the current consumption of the home. Now turn on a load with a known wattage, such as a 1200 watt hairdryer. Tap Next. We are asked if the total home load now increased by the amount expected of the added load. If no, try the test again. If yes, tap Yes to continue. Phase errors are a common installation error, which, if unchecked, could cause the system to operate incorrectly or erratically. Installers should perform a phase check for L1 and L2 to ensure consistent phasing from the main panel to the IQ gateway. The diagram pop-up shows how to check for proper phasing. Confirm you have done this by tapping Confirm. With the PV still turned off, the net power being imported from the grid will show on the screen. For the next step, turn on the PV breakers to start PV power production. Tap the Switch on PV breakers message to begin the timer to show how long before PV starts production. If the loads in the home remain relatively constant, the import number will drop as PV starts producing to help feed the loads. If PV is producing more than there are loads, the message will switch from power being imported to displaying how much power is being exported to the grid. This confirms the operation of the consumption CTs. Tap Next to continue. There is one last installer test to check if the consumption meter is running correctly. If the home has a utility meter that shows power flow, kilowatts, in and out of the meter, you can verify if the home's utility power meter readings matches the reading you see on the installer app. If the consumption readings look good, tap Enable Consumption Meter to complete the meter setup. Click Continue to configure the storage meter if there's one installed and is required for the storage system. To begin the storage meter configuration, ensure the PV is switched on and the IQ batteries have been on for at least 5 minutes. The storage meter measures charge and discharge from the battery circuits using a separate CT placed around the battery circuit conductors. Verify if the batteries are pulsing blue and the installer app indicates storage discharging. Or if the batteries are pulsing green, the installer app indicates storage charging. If the behavior doesn't match, check the storage CT wiring and verify all battery circuits are being measured through the storage CT. Tap Next to continue and tap Enable Storage Meter to complete this sub-step. The last step of system validation is the final system functional test. The installer app should display that all meters are operating and displaying values. Once the meters have been enabled, the functional validation sub-step is the last final operational test of the whole system. Functional validation begins by showing a live status screen which displays where power is coming from and going to. In this example, PV is producing and exporting to the utility grid. PV is also charging the batteries and also supplying power to the home and loads. At this time, there's no power being imported from the grid. The functional validation test checks that NFace system devices are ready, all the meters are enabled, and the battery mode is set up for functional testing. After testing, batteries will be reconfigured for normal operation. The next step in functional validation is ensuring there are some active loads in the backup panel and confirm that the batteries are charging. For this part of the test, we want to ensure that the loads in the backup panel is less than the battery capacity so that when we disconnect from the utility in the test, the batteries will handle the load and not collapse the microgrid. When you're ready, go off-grid by using the toggle in the installer app at the top right of the screen. The system will disconnect from the utility, PV will continue to produce power, and with batteries will supply power to the backup loads. There should be no interruption of the running loads. Verify this was successful by tapping and confirming the system is off-grid and backup loads remain powered. Next, turn on an additional load and allow the load to stabilize for a minute. Verify that the system was able to support the additional load. Tap the box to continue. The next functional test step is to reconnect the system to the utility grid and have the system resync and operate back with the grid. Using the on-grid toggle at the top of the screen, tap it and wait for the system to reconnect to the grid. The final functional validation step is to confirm that the system transitioned back to an on-grid state. you will receive a functional validation is complete message. Then you can tap Continue to finish. After functional validation is completed, the NFace system will schedule and complete any remaining software updates to the system unattended. The installer can leave the site. System is now fully validated and functionally tested, and you can complete any final commissioning steps.